All right, welcome to day two of doing some online stuff. So what we have here is we're doing 3.2. We're not doing the whole thing. We're only doing the first half, which is going to be considered product rule, and then the second half, which is going to be going over on Wednesday, which is going to be quotient rule. So essentially, each of these in the note packet, there's one page front and back for both. So I like to separate them because product rule, I like to do enough examples so you kind of get a feel for it, and then same thing for quotient rule, which I give you enough examples to get a feel for that one. Now, essentially, back in 3.1, right, went over like, hey, if I take a derivative of a number, what happens? What happens if I have x? What happens if I have, x squared, x cubed, square roots? We did certain rational functions. We did stuff like that. Now, one of the things we also talked about there, which we kind of used a good bit but didn't really like emphasize too much, is the fact that uh, we could distribute essentially derivatives across addition. So if I had like a polynomial like x squared plus 2x plus 3, I can take the derivative of all the components separately and get that derivative. Now, we can't do that for multiplication, so I can't just take the derivative of f and g and multiply those results together. That will not work. Same thing with quotient rule. I can't just divide the derivative of both parts individually. It's a little bit more complicated than that. Obviously, quotient rule has more going on than product rule, but product rule is not terrible. I actually do it a slightly different way than you might see if you were to like just straight up Google product rule. I do a slightly different order because I try mimicking the order that's in quotient rule, so you're not trying to like memorize like two different things. They look mostly similar. Okay. So what we're gonna do first is we're gonna look at, what is the rule. So I'm gonna do that first. Then we're gonna have pretty much 6 examples. I try giving you a variety of different ones where it's just, hey, can you just find the derivative? Okay, it looks, ask you similar questions, might look a little bit different. And there's a couple that are a little bit like, uh, I don't keep using the word different, but um, it's just a basic, hey, what's the derivative? Like example three is going to be one where we're like evaluating. So that's going to be a fun one. Example five, we're doing a double derivative. And then for example six, we're doing an equation of a tangent line. So we have some different looks here besides just a basic, hey, find the derivative. Okay. All right. So if we go to our handy dandy whiteboard, essentially for a product rule, if I'm doing d over dx of do bracket f of x times g of x, the idea is we're taking the product of two functions and we need a derivative of that product. Now, another way we can write this is essentially f of x times g of x, and we're doing that whole thing prime. So if you like your prime notation, that's the same way. Now, the way I'm going to show the formula is using the prime notation just because it's just a little easier to look at that way. But essentially, we take the derivative of the first piece times the second piece and not changing, plus, and then we do the opposite. First piece stays the same, times derivative of the second piece. Okay. Another way you can see this written is they do like U's and V's. So we can say it's like this way. So it's U times V prime is U prime V plus U V prime. That's another method. So if you're kind of doing some research and stuff for product rule, this is another variation of the same thing. Essentially, instead of using F's and G's, they use U's and V's. Now, there is some advantages to this method because when you do like Calc 2, they'll use this notation. So depending how you want to do it, either way is fine. Yeah, I can show you a couple examples where we use U's and V's and kind of plug all the stuff back in, or we just kind of think about it. Now again, the way I like to do these problems is I always do derivative of the first times the second plus first times derivative of the second. Looks kind of like this. Okay, so when I'm looking at this, it's going to be f prime g plus f g prime. Okay, if you use the UV method, it's u prime v plus uv prime. So if I do an example to kind of showcase this, so for example 1, we have f of x equals x times e to the x, and we're asked to find f prime. So we're just asked to pretty much find the derivative. Now, as we see, we have x and e to the x. These are two different functions multiplied together. So this is a product rule. So if I do f prime, we have the derivative of the first. Okay, the derivative of x is 1. E to the x stays the same. Plus, now the x doesn't change, times the derivative of e to the x, which is itself. So our answer just be e to the x plus x times e to the x. That's usually how I do the problems. Now, if you want to use the UV method, okay, how that works is essentially use the first piece, v is the second piece. So we say, hey, look, u is x, v is e to the x. Well, what's u prime? Well, that's 1. V prime is just e to the x because the derivative of that is itself. And then we just kind of fill in the pieces. So we go, okay, well, if it's u prime, then v, it's going to be 1 times e to the x plus, then it's u times v prime, which gives us the same result. So depending on how you like to do the problems, if you like listing everything and doing the primes, that's fine. Usually when I do the problems in my head, this is the way I go. I might just keep using the UV method because I think for you guys it's going to be the good middle ground where it's like not super duper complicated, but it's easier to follow. So I'll probably just be doing that for the next couple examples. But again, it's the same thing. It's the derivative of the first times the second plus first times derivative of the second. Okay, no matter which way you slice it, it's the same thing. Now, if I look at example 2, we'll scroll this down a little bit. So for example 2, we have h of t equals the square root of t times a plus bt. We're asked to differentiate, so we want h prime. It's going to equal something. Okay. Now, if I use the UV method, u is going to be the square root of t. V is the a plus bt piece. So the question is, what is u prime and v prime? Well, for u, technically, right, this is the same thing as t to the 1/2. Okay. So if I was to do that, we multiply the front by 1/2 minus 1, so you get 1/2 t to the negative 1/2, which we can rewrite that as 1/2 times the square root of t. And we dealt this problem before, so the first time seeing that. Now for the v, it's interesting because what they are doing in this problem is a little weird. We have these a's and b's. Now what they tell us is that a and b are constants. I was going to erase that right there because that looks terrible. So a and b are constants. Okay. So a and b are constants, meaning that these are just numbers. So if I take the derivative of a, since it's a constant, it gets 0, plus bt, the t drops off, so you just get b. So v prime is just the number b, whatever that might be. Now, if I set this up and put them together, right, it's u prime v. So I'm going to have 1/2 square root of t times a plus bt plus u not changing, I'll just leave the square root of t times v prime, which is going to be b. And now, I would not simplify this, I'll just leave this the same, and we just kind of roll with that. Alright, although you're able to kind of leave this as the answer, well, I mean, we can kind of clean up a little bit. If you really wanted to, you could probably put this as b root t, but I'm not expecting you to have to distribute this across or anything. Usually when you do product or quotient rule, we're a little bit generous on the type of answer, where the way it looks, where we're not making you go through all these, jump through all these hoops to get these crazy answers. We're fine leaving it this way. You don't have to do anything really else. Now, in this particular question, since we did give you something a little bit weird where A and B are variables, but they're constants, you just have to kind of keep an eye out. Now, obviously, you're not going to get a bunch of questions that kind of like that. This one's just kind of there to kind of challenge us to think, what are all those pieces actually doing, and how's it all kind of play out? Now, if we do example 3, this is a more interesting one. So for example 3, let's cut a couple of details that we have. So we have f of x equals the square root of x times g of x. So we have some function that's really unknown that's here to deal with. And we're also told that g of 4 is 2, g prime of 4 is 3, and we're asked to find f prime of 4. So this is an evaluation problem, but we kind of have this weird thing where we have a function's unknown. So we're going to do, our normal derivative for f prime and see kind of what happens. Now, when I do f prime in this case, the first piece, the square root of x, take the derivative of that. We already know what that is. It's just this thing. So it's 1 over 2 times the square root of x. G of x doesn't change. And then when we do the second part, the first piece doesn't change. But the second piece, we take that derivative and multiply those together. Okay. Now I didn't use the UV method, okay, but same idea. Derivative of the first times the second. So the first piece changes, the second doesn't change. And then in the second half, the first piece stays the same, but we take the derivative of the second piece. Now if I plug in f prime of 4, we can plug this in for all the x's and see what we get. Well, it's 1 over 2 times the square root of 4 times whatever g of 4 is, plus the square root of 4 times g prime of 4. Okay, so we know what g prime of 4 is. It's 3. G of 4 is 2. Square root of 4 is 2. So we can kind of clean this up a little bit. So it'll be 1 over 2 times 2 times 2 plus 2 times 3. We can kind of cancel these 2's out. So we get 1/2 plus 6. So the final answer would just be 6.5. Or if you want to feel fancy, 13/2. I'm 5 and 6.5. Although if you want to be fancy schmancy and use a fraction, the 13/2 is also adequate. Now, in this particular case, right, we're given a lot of extra information, and that's because this g of x thing here, since we don't really know what that is specifically, we kind of have to keep it generalized. So when we go through the problem, it doesn't change in the first half, but it does change to the derivative in the second half. So we just have to keep that in mind. Now, what's nice of this question is since we're plugging in 4, we can just plug in 4 for all the x's. We're already told the two pieces about g and g prime that we need, and we just pretty much, replace their values and kind of move along. Okay, so that's an example of evaluating. So you're probably going to see some questions like this on the online homework, I'm pretty sure. And I think there's some question on the paper homework, if I remember correctly. So this is something that you're definitely going to see again for sure. Now, if we look at example 4, we have g of x equals x cubed plus 2x times e to the x. So again, we're asked to find g prime. If I do the UV method, the first piece would be u, so it's x cubed plus 2x. V would be e to the x. So u prime would be 3x squared plus 2. Well, v prime would be just e to the x. And so if I set this up, g prime is u times, or excuse me, u prime times v. So it's going to be 3x squared plus 2 times e to the x plus, now it's u, so it's x cubed plus 2x times e to the x. This is 3 here. Now, if you really want to be fancy, you could technically factor out e to the x here, and you're left with essentially x cubed plus 3x squared plus 2x plus 2. And you can use this as the answer, but I mean, technically, this is fine. I mean, you can kind of leave it like this, and we'll be okay with that. If you want to be fancy, you could go to here if you felt like it, but it's not necessarily required by any means. Now, like I said, I think using this whole piece here makes things a lot easier. That way you can kind of piece it together because, you know, you're, in this case, g prime, right? It's just u prime v plus uv prime. It's kind of the same thing every time. So if this is a little bit easier for you to do, then you can do it that way. I mean, nothing wrong with that. I think this is probably a better way to go through the problem if you're, especially doing the first couple times and kind of getting used to it. This allows us to kind of keep things organized while, you know, still being efficient with getting to the answer. Now, a fun one we have is example 5. This is where we ask you to do a double derivative. So we are saying, hey, f of x is x to the 4th e to the x. We're going to say find f double prime. So what's going to happen is we're going to do the first derivative, and then we're going to do that derivative and do it again. Okay, so a double prime just means you do it twice. So if I have x to the 4th, that's my u. V is e to the x. So v prime is the same thing. U prime, however, is 4x to the 3rd. So if I do f prime, we're going to get 4x cubed times e to the x plus x to the 4th e to the x. I'm going to do it the other way. Actually, yeah, that's fine. I don't have to do that. We could just have x to the 4th. I'll just do it like this anyways. Times e to the x. Now, if I do what I did in example 4, it's going to make my life a little bit easier because we notice there's like 2 products, but it doesn't have to be that way. If I factor out the e to the x, we're left with 4x cubed plus x to the 4th as our answer. But technically we're not done. We got to do it again. So it happens here with f double prime. we're going to use u and v again. So this time u is going to be e to the x. V is going to be 4x cubed plus x to the fourth, which makes u prime e to the x, while v prime is 12x squared plus 4x cubed. And we kind of do the same thing again, but this time though, this is a f double prime. Okay, so f double prime, the only difference is we're using the first derivative's result to find the second derivative. So we're just taking our answer from the first half and then we're just doing it again. So u prime is e to the x, v is 4x cubed plus x to the fourth, and then we do e to the x, because that's our u, times our v prime, which is 12x squared plus 4x cubed. Now, like I said, if you want to be fancy with it, we could technically go one step further, although this is an acceptable answer. We could factor out the e to the x, like we did for the previous questions, and combine like terms of the pieces in the middle. So you get x to the fourth plus 8x cubed plus 12x squared. And you can say this is the final answer if you want to go fancy with it. But again, it's not necessarily required to go and simplify that far ahead. You know, if it's simple, you could do it. This is kind of like in the medium territory. It's not like that hard to do. But there's some questions where you're going to look at the answer and be like, you know, I don't feel like doing that. And that's fine. Okay, you can kind of sleep with that. Okay, so example 1 and 2 and 4 are more basic questions, regular derivatives, nothing too crazy. Example 3 did have an evaluation component. Okay, so we're more worried about plugging something into that derivative. Example 5 was our double derivative, what happens if we do it twice. And then for example 6, we're going to be looking at, hey, how do we find the equation of a tangent line? Okay, so let's go ahead and take a look at what example 6 has for us, and then we could probably figure out how to get that answer. So for example 6, we know y equals 2x e to the x. I'm going to find the tangent line. At the point 0, 0. Okay, so if I'm looking for a tangent line, right, we're thinking y equals mx plus b. Well, this is our slope of the tangent line, right? But we also know that the slope of a tangent line is f prime, right? So we know that this can also mean that m equals f prime at that certain point. Now, this is a derivative. Okay, before the previous questions, we had to do a lot of like limits and stuff like that, but here we don't have to, right? If I know what this derivative is, that can help me find the slope. So that's what we're going to do. So we're going to do y prime. So if I do y prime, okay, u is 2x, v is e to the x, so v prime is itself, okay, same thing, while u prime is just going to be 2. Now if I set this up, we get 2e to the x plus 2x e to the x. Okay, so u prime times v, u times v prime, we have it here. Now, this equation itself is fine, but we don't care about the equation exactly. We only care about this equation at one particular point, right? So the idea here is we really only care about this point, so we got to make sure we use this point with this y prime. So the idea is, right, if I'm looking when x is 0, I'm going to plug that 0 into these x's here. So my slope m is equal to 2 times e to the 0 plus 2 times 0 times e to the 0. So that's 2 times 1 plus this whole thing equals 0. So my slope is 2. Now, conveniently, right, this is also my b value. Okay, we'll rewrite this as a really ugly b. This is our b value. So if I know my slope is 2 and my y-intercept is 0, the equation for the tangent line would just be 2x plus 0, which we just say is 2x. And this would be the equation of the tangent line at that particular point for this equation. Again, slope is always a derivative, okay? So starting at like 2.7, we kind of said, hey, you know, we had the limits to help us find the f primes. Well, f prime is the slope, okay? So since f prime is the slope of the tangent line, if I find that derivative here, then that allows me to plug into it to find slopes anywhere. And that's something I did talk about in class, a few days ago. Last week, probably. So, again, finding these derivatives allows us to find instantaneous slope or the slope of a tangent line anywhere at any point. Now, if I'm asking you to find that equation for the tangent line, first you got to find the derivative. That derivative is the slope when we evaluate at that point. Okay, so I have to take the x out of here and plug it into my x's. Okay, when we solve it, that's our slope. So we got the slope is 2. In this particular case, since the order pair is 0, 0, the y value here is the y-intercept because I told you x is 0. So we kind of got that for free. Otherwise, you have to do what we did before. Either use point slope form and solve it out, or you plug in x and y in this order pair as a test point in this equation to help you solve for that missing component. It really just depends on what you're given, what you need, and have to make the decision how you're going to get there. Okay, so there's a couple routes to get there, but in general, it's not too bad. Now, like I mentioned, we're not going to do quotient rule. That is the next thing, but we're going to pause here. Okay, before you really should try quotient rule, you should really feel comfortable with product rule because you're doing the same thing in that question too. So it's just going to be getting worse. So if you're not comfortable with product rule, quotient rule is not going to be any much better for you because it's the same kind of process, just slightly different equation. Okay, so my recommendation is take a look at the 3.2 paper homework, only the questions that deal with multiplication. Okay, same thing with the WebAssign problems. You can look at that too, and only do the ones that look like a product rule. If it's a quotient rule, skip it for now. We're doing that tomorrow, okay, after the quiz. So I would say get started on some, practice some, do all that stuff. Now, other side note, right, like I mentioned, since we were supposed to have the quiz on Monday, but then I got pushed back to today, and now we're not meeting again, so it's getting pushed back to Wednesday. I'm not adding any questions from the notes we've been doing the past couple days. That quiz is still the same. It's still only on, should be 2.7, and I think the section before that was 2.6. Let me double check. Let's make sure I'm not crazy. I did not put a question in 2.8 on there. Ask you to do the derivative. I spared you from that, but just be mindful. You will have a question like that on the test. But the question for 2.7 is very similar to like the first example or in second example. Okay. Technically, the third question and the fourth question also could work too. You can use either of these equations on the quiz. I would say probably you can get away with doing this, the more basic one for now and not really get too crazy caught up with the H one, but the H one's probably better in the long term, but in the short term, that one's fine. And then, yeah, 2.6, you have some questions with infinite limits. So the first page of the quiz, you have a couple of limits like these. You can use the shortcut. Okay, when you're using the shortcut, it'd be nice if you told me why you're using that answer. So like, for example, if you notice, hey, the bottom is bigger, just write that down and then tell me the answer is 0. That way I know the work, just in case you write the wrong answer. If you indicate you notice what the thing should be, at least I can give you partial credit if you wrote the wrong number. Okay, because, you might think, hey, bottom's bigger, my answer is 1. Okay, that's not the case, it should be 0, but you know what I mean. So you have a couple of those limits on the front page, and there's going to be one question on the back page that deals with, hey, can you find the slope for a tangent line for any of these things. And then I think it also wants you to write the equation too. So make sure you be able to do both. Okay. If you have any questions on product rule, okay, basic derivatives, or stuff related to the quiz, you should definitely email me. That way I can, answer that before Wednesday. If there's anything else that's going on you let me know about, just keep me in the loop. But, I'm thinking this is probably the last video we need to do, but for some reason, if that changes, which it's very, 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 very unlikely, I think, we'll just kind of keep moving forward. But I'm pretty confident probably still meeting on Wednesday. Temperature is supposed to not be freezing overnight, so things shouldn't really freeze after it melts, which is the main issue we're kind of dealing with. So, but yeah, so just keep up tabs with that. I keep you in the loop. If you have any questions, just let me know.